May have heard of the amazing feat produced by ISRO, or India's Space Agency, where they successfully inserted a probe into Mars's orbit on the first time of trying, for a relatively minuscule $66 million back in 2014. This made it the first space agency in the world to have a successful Mars mission on the first time of trying, plus it is the first Asian agency to get to Mars. This by itself is pretty impressive, but it's been in orbit for over 5 years now. So what has it done and seen around Mars? And has it contributed anything beyond what the NASA and ESA missions have already achieved? I'm Alex McColgan and you're watching Astrum, and together we will investigate the findings and imagery of the Mangalyaan mission to Mars. Mangalyaan launched from India in 2013 on board an ISRO rocket designed to insert satellites into orbit around Earth. As the rocket didn't have the thrust needed to get Mangalyaan to Mars, the probe had to use some of its own fuel to leave Earth orbit, which it achieved gradually over several orbits. Upon arriving at Mars, it was inserted into a highly elliptical orbit. At its furthest point, Mangalyaan is almost 80,000 kilometers from Mars, and its closest approach takes it only 420 kilometers above its surface. This orbit is much different from NASA's Mars Reconnaissance Orbiter, which remains close to the Martian surface in order to image the surface at a much higher resolution. This is due to the different science goals of the missions. Mangalyaan does seem like more of a technology demonstration mission, although scientific instruments on board had a particular focus to study Mars's upper atmosphere. However, what I really like about this mission is that they put a pretty normal camera on board to image the Martian surface. This means the raw images are true color images, seeing Mars as you would see it if you were in orbit. Having a highly elliptical orbit also means we can view the whole of Mars in one go, reminiscent of the old NASA Viking missions. I must say that at this distance, Mars is a beautiful planet. The carbon dioxide and water ice caps are visible at the planet's poles. Various shades of rock sediment and dust patches across the surface provide an interesting contrast. Craters of various sizes span the planet. And of course, some of Mars's most interesting features are visible, like its long dormant shield volcanoes and huge valley structures. What's also visible, even from this distance, are some of Mars's famous giant dust storms. In this image, the dust storm spans thousands of kilometers across the northern hemisphere. These storms can last weeks to months, almost completely blocking sunlight from reaching the surface under the densest parts. Storms like these caused big issues for the solar-powered rovers Opportunity and Spirit. Some smaller storms can also be seen in some of the other global views of Mars. Orographic clouds are often seen over the volcanoes of Mars, and yes, these are water ice clouds. Although the atmosphere of Mars is a lot thinner than on Earth, and most of its water has been lost, there is still a small amount of water vapor in the atmosphere. And in this image, we see 3 smaller volcanoes, with orographic clouds forming over Elysium Mons, the center volcano. Orographic clouds form when air is forced higher as it moves over high terrain. During a closer approach over Elysium Mons, clouds are still visible, but more apparent are the trenches around the volcano. These are called fossa, trenches formed by the stretching of the plate they reside on, often caused on Mars by the sheer weight of the nearby volcanoes. The fossa widen as more material falls in. Think of it like a series of connected sinkholes on Earth, but instead of material being eroded under the surface causing the pit to open up like on Earth, on Mars the cause is due to a fault under the surface, sometimes up to 5 kilometers deep. A close-up examination of one of the fossa reveals something interesting. Right in the middle of this image, you can see what appears to be a tall, wavy structure. Mangalyaan inadvertently captured a giant dust devil, the shadow of which stretches out for several kilometers. Once you notice that one, you'll realize there's actually a few in the image, each with a long, windy shadow. Orographic clouds have also been seen over Olympus Mons, the tallest volcano in the solar system. From the base to the peak, Olympus Mons is 3 times taller than Everest and is 600 kilometers wide. As a result, it is easily visible and recognizable even from this altitude. From this view, you can also easily see where lava from ancient eruptions has flowed down onto the plains surrounding the volcano. Looking a bit further across, you see 3 more big shield volcanoes, with a few smaller ones to the north. You'll also start to notice this weird patch, which looks almost like a labyrinth, aptly called Noctis labyrinthus. In a similar vein to the Elysium fossa, Noctis labyrinthus is thought to have formed because of the huge volcanoes to the northwest, but this time perhaps due to collapsed magma chambers deep under the surface. Research is ongoing. Connected to Noctis labyrinthus is the famous scar of Mars, Valles Marineris. What I really love about these images is that, just like the Viking missions, water ice fog can be seen filling the chasm. This valley is 4,000 kilometers across, and channels seem to flow out of it to the east into chaos regions, similar but smaller than Noctis labyrinthus. This hemisphere of Mars is lower than the rest, which indicates these outflow channels, which do look a lot like river channels on Earth, flowed into a once ocean. Ground-based rovers have since uncovered further evidence for this ocean, finding hydrated minerals in these regions. Another really interesting visual landmark on Mars is Kasai Valles, north of Valles Marineris. Again, this shows a very interesting outflow channel, starting in the east and flowing to the west, depositing into the same region but further north as Valles Marineris in the south. Most scientists propose these channels are carved out by mega flooding events in the distant past, when liquid water was abundant on the Martian surface. There's also some argument that glaciers carved out these channels. In fact, there are a lot of outflow regions heading into this once ocean. Here's Ares Vallis, again probably carved out by mega flooding events. All these channels are too wide to have supported a constant river system, at least at this size. A very large yet odd crater-like structure can be seen from the Mangalyaan images. This is Orcus Patera, 380 kilometers long at its longest point. Scientists are a bit baffled about how this could have formed. Craters are always circular, plus Orcus Patera isn't very deep at only 500 meters. Volcanic activity could be a cause, but there's no cauldron, and so there have been no theories that scientists can settle on so far. What do you think it could be? Some of the images focusing on the limb of the planet have also been able to see Mars's atmosphere, which I think is quite beautiful. Some very oblique shots can even see a cloud layer high in the Martian atmosphere. And due to Mangalayaan's ecliptic orbit, sometimes Mars's moon Phobos comes between the planet and the probe, imaged here against the backdrop of the planet. The last thing I want to showcase in this video is the prevailing wind direction on some parts of the planet. Even though we are quite zoomed out by here, in this image, showing a few thousand kilometers across, we can easily see where craters have blocked the darker dust from moving across the surface with the wind. The wind direction in these parts must have been like this for a while, for it to be so noticeable from space. A closer look at the surface shows how this effect can happen with smaller craters too. I've really enjoyed making this video, looking at a far more zoomed out view of Mars than what the high-rise camera on Mars's MRO could provide. This has meant we could explore some of Mars's largest features as a whole and what they actually look like from orbit, and not zoomed in sections. I believe both types of missions have their place to further our understanding of perhaps our most intriguing neighbour. Did you enjoy learning about what Mangalyaan saw today? As you can see, learning about science, or maths for that matter, doesn't have to be dull. In fact, if it wasn't for maths and science, missions like this one wouldn't be possible. Want to know how it was done?